Approximately 77% of people experience physical symptoms such as headaches, muscle tension, or fatigue caused by stress. Yet, when panic thrives, it's extremely hard to immediately know what to do to ease it. However, there are some common practices that can help reduce stress. First, a simple exercise or stretching can help relax and relieve muscle tension. And workout systems don't need to be structured like Pilates or yoga. Even a small walk can release the nervous system. Second, mindful meditation is one of the most research-proven techniques that requires concentration and observing mind thoughts without getting swept away by them. It reduces overthinking, anxiety, and negative thoughts. And finally, box or square breathing is a technique that has 4 equal 4 seconds intervals. Inhale for 4, hold for 4, exhale for 4, and hold empty for 4. And it helps activate the body's relaxation response. All of these techniques are different but effective. However, stress can make it difficult to recall and apply them in the moment. That's why I decided to create a computer vision system that, when activated, initiates box breathing system and helps users track their blinks and breath to analyze their behavior. Actually, computer vision includes many algorithms, such as object detection or noise reduction, and many more. But for this exact project, the most convenient ones were pose detection and face detection. So I used Python library called MediaPipe that has 470 face landmarks and 33 pose landmarks. So in the end, I built a computer vision system that can provide box breathing pattern, track users' blinks and breath, and give non-aggressive feedback based on users' breathing cycles. Let me show you.
Inhale. Hold. Exhale. Hold. Inhale. Hold. Exhale. Hold. Inhale. Hold. Exhale. Hold.
Now let me walk you through how I built it. But first of all, why even track blinks? And actually, blinking can reveal a lot about the person's mood or condition, because during stress or anxiety, blinking rate will most likely increase, while when people focus on something or complete cognitive tasks, their blinking rate can decrease. And actually, blinking tracking system was pretty straightforward. For it, I only needed one eye, so I've chosen the left one. And I needed to track left and right corners of the eye, as well as top and bottom centers of the eyelid. Looking at the picture, that would be P1, P4, P2.5, and P5.5. In MediaPipe, these landmarks are numbered 159, 23, 130, and 243. Once I had those points, I calculated the vertical distance, aka how open the eyelid is, and the horizontal distance, aka the width of the eye. When the user blinks, the vertical distance approaches 0, while the horizontal remains the same. However, simply checking if the vertical distance was less than a threshold wasn't really enough because 1. People can have different eye sizes, and 2. They can sit at varying distance from the camera. That's why I used ratio. So I counted vertical distance relative to the horizontal distance. For easier analysis, I also added a simple plot that visualizes how the ratio changes over time while the system runs. The blink counter adds one blink whenever the calculated ratio falls below the ratio threshold. However, since the system processes images every frame, which happens obviously faster than a usual blink, I had to implement a mechanism that waits for 4 frames before allowing a new blink to be detected. Without it, one blink would be counted more times than needed, which definitely wouldn't help stressed people. Here comes the most important part of the system, breathing detection. For it, only one shoulder was enough again, so I used the left one. When the user inhales, it rises, and when exhales, it falls. And that's exactly what I used, vertical movement. My system has 2 states. The first one is way up, that waits for the inhale, and the second one is way down, that waits for the exhale. So when the shoulder moves up, it registers an inhale, and it waits for the exhale. And then when the shoulder moves down, It registers an exhale and says that it was a complete breathing cycle. This way, camera distance won't affect accuracy because all the movements will be measured relative to user's initial position. However, sitting still is essential because even tiny movements can be considered chest movements or breathing by the system. So now about box breathing cycles. My system has 4 phases: inhale, hold, exhale, hold, and every frame it determines which phase it's currently in, and based on that displays text and plays an audio. And until the variable finished is true, it will repeat the same structure over and over again. So currently in my system I have only 3 cycles of breathing, but this number can be increased if needed. And if the user's breathing count was exactly 3 times, the system will congratulate the user. However, if the breathing count doesn't match with the number of cycles, it will suggest trying again. However, I also have to mention challenges I faced during development. And first of all, landmarks. Although on the video you can see that it can detect my shoulder even through clothes and my hair, it can be a little bit messy, especially if I don't see in a well-lit room or have oversized clothes. And the second problem was blinking. Sometimes the system can distinguish actual blinks from small eye movements, so when I look downwards like this, it will think that I blinked. And while making the system, I also came up with some future improvements that I can focus on next. And first of all is ML model. Instead of just counting blinks and breath, I can use a machine learning model that will analyze these counts and actually predict if the user is stressed or not, and if yes, to what extent. And another thing that can really help my system to be more accurate about the user stress level is actually the taking user's pulse. There's a computer vision system that can analyze the forehead subtle color changes caused by blood flow, and based on that, estimate users' approximate pulse. And finally, adding some more breathing techniques would also benefit users because it will help them manage their specific situations. Thank you so much for watching this video. I hope you enjoyed listening to my path of making this project, and I hope you found it interesting and useful. Bye!